So let me start with the elephant in the room. So this is the as you will see in the rest of the slides. I like to put like a nice theme on my slides so they are kind of beautiful. I spend a stupid amount of time, but the first slide is always the corporate thing, right? And I have like the corporate slide already done, but like my company was like, no, you need to change the slide, and I was like, why? It's like, because do you see that copyright notice here that nobody can read? It says 2022 before. You need to say 2025. Like, okay, I will change it. And they provide me this slide with the date wrong because it is like, which it says September. You see, well, not my fault. All right. So cool. So keynotes are a bit different, right? Because like you need to basically withstand me for 45 minutes, which is a lot. Like I speak quite fast, and I know it can be quite intense. So keynotes normally cannot be super technical because like people cannot like hear you talking about technical stuff for 45 minutes. So I was thinking always in my keynotes like, how can I make the time of the people that are hearing me the best? Like what can I teach you that you're going to find it more useful? So what you're going to hear is basically like my own perspective of like something that I think a lot of people secretly struggle with, and like this is not something that we talk a lot, which is like career paths. Like what do you do with your life? In particular, you spend a lot of your life like doing your work, right? And like in particular, you're doing Python, but you're using Python for something else. And like that is a surprisingly complicated topic, and like how you approach career and like how you approach decisions and things like that. So I try to condense basically in this talk like as much as I could of how I approach this and like the lessons that I had and like what things I think are more important. So maybe it teaches you something or like changes a bit your perspective. But first, I'm going to start with something interesting. So what you're going to hear right now is one of the most interesting conclusions of this talk, which you're not going to understand anything at this point, but you will understand at the end. And hopefully you will only be able to understand this thing once you listen to the entire talk. But let's listen to this. So this is an interesting sound. For now, I just want you to listen for like 20 seconds and like start maybe guessing what this is, like where is this coming from. Sounds surprisingly musical, but like maybe a bit like like monotonic. So something is going on. Mysterious. So let's continue and see what's going on. Okay, cool. So I'm Pablo Galindo. I like to present myself like my code runs on your computer. Which sounds a bit threatening, but that is true. This is and this introduced me to quite an interesting thing because a lot of people, when they hear core developer and whatnot, but like they don't know exactly what it is and like what is the responsibility. So I guess I wanted to start here and talking about like Python, which is like quite wild when you think about it. And in particular, I'm not a serious person. You can see here the Steering Council like panel of this year. This is like a very serious meeting in front of like almost 2,000 people. And here you can see me with these stupid ears, just because someone told me that if I humiliate myself with these ears, they will donate to the PyLadies, women around the world can like learn more Python. So I say yes, of course, because like I'm not a serious person. And this is one of the things I want to try to convince you here. Like people think about core developers and like like the people that are doing the language, like these stupid people in suits that go to these rooms and say, oh yeah, let's put an if only here, yeah, a for loop, oh yeah. And no, we are just clowns. And this is what I'm trying to convince you as well. Like you can also be a clown. Amazing. So one of the hardest things and most scary things that you need to do when you're a core developer is deal with this button over here. It's a very scary button because when you press this button, like everything changes. And I wanted to show you about like, this is a bit of an exaggeration just because like we are not thinking about this all the time. But I wanted to show you just a sneak peek of like how much pressing this button can change when you're in charge of the biggest programming language. And this is because like Python is quite a big language these days. Like if you go to one of these like arbitrary indexes of popularity, you will see in particular the TOBE index, like Python has been the first one for years. Not only that, like this thing is even growing more. Like right now, this is the last result as of last week. And this is like growing 10% like from the previous version. Like this is leaving all the other languages like super behind. And this also shows you like an interesting picture because like if you think about Rust, which is like a lot of people talk about Rust like being super popular, the rest is not even in the top 10, right? You can see Java, which is like, that opens a bunch of questions, but like, let's not answer those questions here. And Visual Basic, Jesus Christ, I have not Visual, like, wow, that's dangerous. Okay, cool. But Python is quite popular, right? And it runs almost everywhere, and it keeps running more and more and more because like right now with all the AI stuff, it tends to be quite important. So I asked myself the following questions. So given like how much this is growing and how much this is being used, what happens if I press that button and something changes? In particular, let's say I'm going to let's do like an experiment. What happens if you press the button and you make Python 50% faster? Like what will happen? Well, if you make Python 50% faster, basically you can ask the following questions, like if Python is more efficient, then it will require less energy, and that will basically translate to less amount of CO2 released to the atmosphere. What is that number? Well, that number tends to be basically 15 millions of metric tons of CO2, which is a lot. The number basically was calculating using a bunch of like papers, like estimating how much like developers are worldwide, how much of those is using Python. So I spent like 3 or 4 hours basically chasing this thing, looking at like, estimates of how like these big companies using Python and how much that they spend. And also another thing that you need to think about when you think about these numbers is that improving Python can have a big impact, particularly for instance, because it's 75 times more energy inefficient than C. If you will make the C language like 50% faster, because C is already super efficient, that will translate to almost nothing, because like this is already not consuming a lot. But because Python is very inefficient, like making it 50% faster is like having a lot of impact, right? And if you go and like go through the numbers and basically calculate this like very abstract thing, you will arrive to the basically number that I gave you, which humans are really bad on numbers. So let me give you some translations of the number. That number is equivalent to basically planting 500 million trees, or remove 2 to 3 million cars, or basically eliminate all CO2 emissions for entire countries like Lithuania and Slovenia, which sounds very impressive. But then when you look at like how much this is of the total CO2 emissions in a year, this is just 0.02%. Turns out that cows are very bad at this. They have methane and a bunch of stuff, and like, planes and whatnot. So still not making a ridiculous impact. But like I was thinking, like even just like think about how easy is the action to press the merge button, right? And like suddenly you move this number. It's quite ridiculous when you think about it. Obviously this can translate as well in the opposite direction, right? Like maybe you merge a PR that looks okay, but then for whatever reason you don't notice that it makes Python like, let's say 2% slower than some mega benchmark or like some AI stuff, and now you are releasing more CO2 to the atmosphere. I can promise you that no developer thinks in those terms, so we are not like looking at the merge button. It's like, how many CO2 tons of CO2 I'm going to release with this day. But it's quite wild when you think in these terms, because like it shows you like how much impact can you have when you have like such a big responsibility in your hands. Cool, but that's Python stuff. So how, like a question that a lot of people ask me about is like, how did I arrive to do Python? Because I'm not a computer scientist. I am an imposter. I'm a physicist. I'm just like here trying to be cool, but I'm not one of the cool guys. When I was studying physics, I was really studying, and I met Python for the first time. I was studying physics, my PhD, and my PhD is about black holes. And I was basically dealing with these disgusting equations, really complicated stuff. And these are equations tend to be so complicated. These are the questions that basically describe how light moves around black holes and whatnot. And these equations are so complicated that like you cannot just solve them. So you need to throw some computers at the problem. And, obviously those simulations were not done in Python. Those simulations were done in CUDA before CUDA was a thing. Well, obviously not a thing, but like before it was popular, and before all the ML people started to talk tensors and things like that. But these are tensors, by the way. These are real tensors. You see, they look scary because they are scary. But the thing is that like I have to use Python a lot to basically move data around, and basically the same reason Python is used these days. And the cool thing is that when you do these things and like you simulate these things, you can produce very cool images like this one. So for instance, this is one of the images that I was creating my PhD. Now, these are super popular since the movie Interstellar. But what you're hearing here is a rotating black hole, like the shadows are rotating black hole. That's the black part over there. And what you're seeing here is one of the most cool parts of general relativity. This ring that you can see around is not really a ring. It's a single star that is behind the black hole. And because the black hole is deviating light all around itself, it's like bending the light in all directions. That single star that sits behind the black hole emits light that curves in all possible directions, and you see it as a ring. This is so cool and so amazing that this is used as a test of general relativity plenty of times. If you Google Einstein cross, you will see one of the most famous cases of this effect, when like you have a black hole which is big enough, and then you have like an entire galaxy behind it, and you see 4 copies of the galaxy, because like there is dust and whatnot that doesn't allow you to have a perfect ring, but you will see like 4 copies of the galaxy in like all the cardinal points that they're really just one galaxy. And it's very cool because if you point your telescope to every of the copies, you will see that they emit exactly the same light. That's how we know it's the same galaxy and not four of them. And this is with that, like knowing how this distorts space-time, we can calculate how big is the black hole, which is quite cool. And like my one of the things that my thesis was about is like give enough mathematics to make this kind of thing more efficient. And obviously you don't see these things this way. You normally will see in the movie Interstellar like something that looks like this, which now you have like plasma, like, you know, circling about the black hole and falling into. And what you can see here, like all these like weird like rings, is basically the ring being distorted by the black hole. If you right now doing the following thing that I'm going to show you is very easy because like computers are fast these days. But when I was doing my PhD, the movie that I'm going to show you took like 3 weeks to render. Something that you can do here is like take some nice photos or even a video. Hopefully you can see it here, and you can see here a video of like a camera going around the black hole, and like you can see a bunch of cool effects. Particularly, you can see 2 rings over there, but technically it's just 1 ring. And what happens is that the inner ring is just light that is being bended by the black hole a bunch of times and being emitted in the center. There is no second ring; it's just like a shadow of the first one. And when as it turns, you can see actually how the inner ring is bending to be the outer one. You see it there, bonk. Like look at the inner one, and then when it turns, it becomes the outer one, and that is because the light is being distorted around. And this is very cool. But you can say, hey Pablo, like this is actually much cooler than all those like CO2 like Python stuff. Why you stop doing this? This is quite cool. Well, the reason is because like one of the things that, you know, I was super excited about is that you can actually use this thing for something pragmatic, right? And one of the things that you will see if you study, like, for instance, the center of the galaxy, and then you look with your telescope at all the different stars that are in the center of the galaxy, is that they are doing something very weird. For instance, this is a movie of like several years of observation, and you can see that all these stars are orbiting something, but there is no star in the middle. There is just black. So if you actually chart this, you will see that basically all these paths are orbiting something over there, but there is nothing over there. And then you can see, wow, maybe that is a black hole. And like maybe observing how these like, you know, stars are like moving around, you can infer things about the black hole. This is the important thing. You don't know what it is because this is science. You cannot just say, oh yeah, maybe it's a black hole. And like if it's a black hole, it's this big, right? You need to actually prove it. And to prove it, you need to actually look at it like we did several years ago and produce like nice images. But you need to have like some other image that is simulated that you can compare this image to and say, okay, if it's a black hole, it should look like this, or, you know, like I will compare this. And this is something that I wanted to do a lot, and this is what was driving me at the time, and was my objective. And as you can see, that was a big thing some years ago. But turns out that science is kind of sad. Because science is not all about like those things, and there are things that are super cool indeed. Like for instance, this is one of the results I'm more proud about. This equation over here, which you don't need to understand, you don't need to be scared about, but this equation here tells you what is the maximum time that it takes for a ray of light to fall into a black hole. And as you can see, the math is quite complicated, but the answer is quite simple. It's 2 pi times the mass of the black hole. So if you normalize by the mass of the black hole, the answer is 2 pi. And because there is nothing specific about your election of things in this formula is universal. It means that it doesn't depend on anything other than nature itself, which means that you can use this as a definition of pi. This is an alternate, like this is a valid alternative definition of the number pi. It's like literally half the time, the maximum time it takes to fall into a black hole, which is kind of crazy. So next time someone asks you like what pi means, you can just drop this thing and like impress them quite a lot. Maybe Hugo could use this information to put it in the release notes of Python, you know, like quite cool. Cool. But science is not all about like these things, and this is precisely what I changed, because it turns out that like, you know, science is quietly like sad in my opinion. The reason is because most of the time you're not actually doing science. You're actually like trying to convince boring people in the government to give you money to do science, and like those people don't care about anything that you do. They just care about fancy words and whatnot. And like not only I was spending more time doing this, but like after years and years of like trying to do academic excellence and whatnot, my salary was really super sad. I was earning like 700 euros or 800 euros a month, and my rent was like 600, so it's ridiculous. So I had to basically make a very hard decision to move from science to the industry, right? That's when I said, well, maybe doing this Python thing is going to be something. But like this is a big problem, right? Like when you are doing something that basically is your passion, and for me, science was my passion, right? And then you, for whatever reason, you need to move, either because you're forced to, or because you find out that like you cannot do it anymore, or because something else in life, something very deep inside you breaks. Because like the reason you do things despite your salary, despite the fact that like you need to deal with this like paperwork all the time, is because this is something that you love. And when you need to abandon something you love, it's not only sad, it's like breaking, like something in your very soul breaks. And this is something that happened to me, but I have to change because I knew that I was not going to be happy doing science. So I started to study computer science because, like, I have just knowledge of Python, but I have no idea of anything else. I have no idea of databases and like algorithms and whatnot. So for 6 months, I went to the same cafeteria and I studied all computer science. Amazing. And then one of my friends went from the institute that I was working on and went to work to Google. And they said, "Oh man, like you should work here. Like they have free lunch." I was like, "Wow, free lunch. That is what I want to do. I will abandon science for free lunch." Uh, I put an objective, and my objective was I must go to Google. Like that's what I must do. So I did that, and I applied to Google, and I passed all the interviews. So they fly me to impress me into the London offices, and I did the on-site interview, and all of them went really well until something happened. This guy went into the room and showed me this thing and said, "This is a grammar of a language." Does anyone recognize the language, by the way? This is Perl. So he wrote this thing on a whiteboard, sorry, and said like, create a parser that parses this language. And I was this tiny person, like 22 years old, whatever, like scared of like Google and the free lunch, very impressive. So I was very impressed about all those free lunch, and I was like, here, and I knew how to do like a bit of parsing. I have done some exercise on like parsing a bunch of numbers and a calculator, so this was clearly out of my league. And I did the best. And actually, I created a parser that indeed was parsing this language, except that the parser was disgusting, right? Because like I didn't know about parse theory and whatnot. So I failed the interview and I never went to Google. But like then, like remember this because it's going to be important in a second. But like then I applied to Bloomberg when they don't have bullshit interviews. So I actually passed, and now I've been working there since then. And that is a very interesting like first lesson. Like having like being laser focused on achieving something, which is like what people tell you should do about like be laser focused on like your objective and don't let it go. Like that can lead to like a lot of frustration and a lot of like problems along the way. And you will see that there is an interesting aspect of this. So sad. Pablo didn't went to Google, but Pablo ended in Bloomberg. Much better. I don't have free lunch, but I have a lot of friends. That's actually better. Cool. So again, like this is showing you like expectations can be like a bit complicated, and especially when like you have something that you really want to achieve, and like for whatever reason you need to abandon or switch directions. Being too rigid is kind of a problem. So let's go to this thing. So this thing is something I have tattooed in my arm. It's in my right arm. And the reason is because when I switched to Bloomberg and I was already accepted and it was a reality, it's like now you're going to be a software engineer with maybe free lunch someday. But like I was still sad because I was like, man, like I really feel like I'm a scientist and I kind of lost it. So I was really afraid to lose contact to the person I was, right? Like the person who loves science and the person who loves all these things. So I thought about the hardest equation I could write that required literally every single thing I learned during these 8 years of my life, which is this one. This is Hamilton equations in symplectic form, which sounds very impressive. But it's also like very nice and it has a lot of Greek letters. Amazing. Even this iota, which people think is a weird I, but it's, you of course know what it is. So yes, that's the advantage to Greek people. People of culture, right? All right. So I tattoo this like when you go to a mountain and maybe you don't go to the highest part of the mountain, but you go to some respectable part of the mountain, and then you plant your flag and say, this is how like the farthest point I arrive, and I plant my flag and I will go down. I didn't arrive to the top of the mountain, but this is good enough, and this is my flag and this is my equation. So I put it here so I didn't forget where I came from. But since then, things have changed a lot because now I'm doing Python. And in particular, a big project that I did with a bunch of people is dedicating my life to parsers and symbols. So I'm going to talk about this. So this gentleman over here is Gukesh Langa. So Gukesh Langa is one of my friends from Python, and he's also the creator of a formatter that you may know about. It's Black, the Black formatter. Who knows about the Black formatter? Very cool. So let me tell you about the story that happened when I met Gukesh Langa. So we met together, and Gukesh told me about this tiny problem. So let's say you are importing a module in Python. You will use this syntax, and that's kind of cool. But then sometimes that can happen is that you can actually name the module. This is a bit stupid because I'm using food twice, but like you can give a different name if you review your slides. But and this line gets a bit bigger. Obviously, you can also change the name, and if you use a longer name, it becomes even bigger. and you can import several things, and then you can name those things. And now the line is so stupidly big that it doesn't fit into one line. So something that the black formatter will do, or you can do, is to use the power of the syntax of Python and put this thing on different lines. Wow, amazing. And this is so amazing because now you can have these trailing commas, which are really cool. These commas over here will save you in code reviews, because now if you modify the line, it only will show you line modifier that are the one that you change instead of the whole thing. That is pretty cool. And it turns out that something very important in language design is called internal consistency, especially in the grammar. And the idea of internal consistency is that if you have n things, you have n times n minus 1 over 2 possible combinations of those things. So those things grow very quickly. They grow quadratically. And the idea here is that a language is really good if you learn a pattern, for instance, that you can do this operation in which you can split the operation in several lines. If you can repeat that pattern with other patterns, then it's much easier for you to understand the language. Indeed, in Python, you can do literally this thing, for instance, when you import stuff in Python, but you can also do this thing when you define things in lists, right? Like you have a list that is very long, you don't need to do it in one single line, you can do it in several lines, and you can do these things. You say, well, the square bracket is the creator of lists. What happens if I change to the creator of dictionaries? You can also do this thing, like it works. You can split it in multiple lines. If you have a tuple, it also works. Instead of a tuple, you have a function call, it also works. It's literally, as you can see, the same structure. If you have now a function definition, it's exactly the same thing. And if you have, like, again, like an import, it's exactly the same thing. Or if you have a with statement, it's exactly the same thing, right? Oh no, except that it doesn't work for with statements. That makes you sad. And actually, now you can know why one of the bigger problems of Black, because Black likes to format the thing this way, and a lot of people were complaining about the sad face of Black. And the sad face of Black is like that it creates this like little parenthesis colon at the end, which looks like a sad face. A lot of people hated it at the time, but now people don't care. And this was the problem that Lucas Lange told me about, that this trick of splitting things in multiple lines and using parentheses around works with everything except with statements. And Black also wants to format your with statements as well and put them in multiple lines instead of having the ugly continuation bullshit that everybody hates. And that was not possible because the Python parser didn't allow it. So at the time, I read a lot of books about like parsers. All these books here, they are super, super interesting. And I found like one of the passions that I discovered doing this journey is like parsers. I really like these things. So I read all these things, and I talked with Guido for the first time in the Cordova sprint of Meta in some year that I don't want to remember because it would make me feel very old. And we started to, think about the idea of changing the Python parser. And the Python parser is something very complicated to change because it was added at the first commit of CPython in December of 1991, which is the year I was born, which is kind of crazy. So it was a big complication. And it turns out that changing a parser is not easy. For instance, this is a bunch of code. Who thinks this code is Python? It looks like C++ almost, right? Well, this is actually Python. This is the AST of that code. This is just to show you that like what you think is Python and super readable and super friendly is just something that you think. Like Python allows some disgusting things. And this is because like what makes Python readable is your version of the code and how you write code, not what the language allows. The language allows a lot of atrocities. And in particular, like you will find that it's important to understand like how do you define what a language is. And for Python, we have this thing in the grammar. So the grammar is basically a file when we have a bunch of rules, and rules have names and descriptions. And this will look, you will see that they will look very much like regular expressions. So for instance, a rule can have several descriptions, several options in the descriptions. And this is important because you will see why this, like the context manager was not possible. So basically, you go to this file, you will find that you can write a rule name as several possibilities. We use this pipe operator to say this or that. It's like the or. And then every rule can be like regular expressions. For instance, this rule name is uppercase A, like one or more times. But you can have something like this uppercase A 0 or more times, almost like regular expressions. You can also have the square brackets to say optionally this other part. So you can say this rule is either the letter A or optionally this other thing. And then you can start composing these things for having something like more complicated. For instance, this grammar over here describes like a simple mathematical operations with a calculator. If you go to the actual Python grammar, you will start seeing things like file input, which is like a Python file. And you will see, a Python file, what is that? So you start like going into the different names. For instance, you say, a Python file is a 0 or more statements. What is a statement? Okay, a statement is a simple statement or a compound statement. Okay, what is a simple statement? And then you go down and down, and then you can see things that now they're a bit more familiar. For instance, you can see that compound statement is either an if or a while or a for or a try. So you can see here all the things that are possible. And if you go to those things, you will start seeing things like those things. Like for instance, the yellow parts are like literally they're called terminals because that doesn't expand anymore. For instance, if you go to if statement starts with if. Like you don't need to expand if anymore. If is the word if. So if you find if, then that's good. And then you go to name expression test, and then you need to find what that is and continue going forward. So this is what is a grammar. So it turns out that, like these terminals and non-terminals are quite important, because if you go to the while statements, you will see that after the while, there is this name expression test. So you will need to go into that other rule to know what's happening. And this go into the other rule can become very complicated in a second. So it turns out that we designed Python grammar to be an LL1 grammar, which sounds very technical, but it's very easy. This just means that you need to read the grammar from left to right, as opposed to the other way around, because that's a stupid choice that people could do. But most people shouldn't do this because it's harder. And the one means that if you are in a particular symbol and then you have several possibilities, like this could be an if statement or a for statement or a while statement, and you need to know which one of them to follow, you can only look one token ahead. Like you could technically look 6 tokens ahead, like 6 words ahead, but in LL1 grammar, the parser will only allow you to look at the next token, which is a very simple thing, but turns out that if you do that choice, then making the parser is a bit easier. And that's what we do design. Not only because the parser was a bit easier, because it makes the grammar much more simple. And that is what keeps Python, or at the time, that's what kept Python really, really simple and not super complicated. And that is what translates as you thinking that Python is very readable, with at the end is a very, very technical description. So for instance, this is the Python grammar, and you will see like a bunch of those terminals and non-terminals. And one thing that you may be interested on is saying, well, if I'm only allowed to look at one token ahead, and I have 3 possibilities, imagine if, for, and while, and I have the token raise, well, I know that I cannot go anywhere, right? Because I can only go to for, and for starts with the token for. I can only go to if, and that starts with if, and I can only go to while, and that starts with while, and those are my 3 options. So if I have something else like raise, then I know that the program is invalid. So that kind of like all the tokens that you can parse, they are called the first sets. And these are the first sets of different things in the grammar. For instance, you can see that obviously the print statement can only start with print, but something like a simple statement, which is any statement, can start with assert or del or exec or like blah, blah, blah. So the parser uses these tokens to know which one to follow. And this is the problem. The problem is like for something like the will statements. Let me show you directly here. The problem is that if you want to write this thing over here, when you see the open parenthesis, that is a problem, because the parser doesn't know if that open parenthesis is a parenthesis because you are grouping the with statements like this case over here, or because you are going to write a tuple. Like it doesn't know which one of the two. So this is what is called an ambiguity. Like the parser has 2 possible paths and it doesn't know what to follow. And this is very important, and you need to remember. This is because LL1 parser, which is a very classic parser, it has only one possibility to go ahead. It needs to know. It cannot try the parentheses and then like try the next tuple. It cannot like, okay, let me see if I can do it this way, or it cannot even receive an instruction from you and say, if you are in this ambiguity, do this. Like, it's a mathematical construct that is very rigid. It will follow only one possibility, and if it cannot follow the possibility, then it will fail. And this is the reason with the old parser, we couldn't have this nice with statement. It was just mathematically impossible. So something that the other problems that the parser had is that even if you think that the parser was very simple, writing some rules was not. This rule that you can see here is basically the grammar definition for function parameters. Not the functions themselves, as function parameters. This is very hellish. If you ever need to modify this rule, you will find that you will spend hours looking at this and you will hate your life or your decisions. So even like if people say, well, elegant grammars are super simple and they're super easy and like, very easy to follow, like it turns out that for real languages like Python, they start to like require all this madness, which is not fantastic. So something that we did with Lisandros here and Guido is that we decided to change Python parser. We decided to remove the parser that was served for almost 30 years and change it for a new thing. So we created a new PEP that changes the LL1 parser for a new parser, which is what's called a PEP parser. As you can see here, the comments when the first LL1 parser was introduced. That was introduced for the first time in the first commit of CPython in 1990. And the PEP parser was introduced in 2020, so almost 30 years, which is ridiculous. So after this PEP, Python gained one of the most powerful parsers that you can throw in a language, which will allow, as you will see, not only like much better error messages, but super advanced construct like pattern matching and a lot of the new grammars that we have, which impact millions of developers. But working on this, I met Lisandros, and I gained a friend, and I think I was the one who won the most. So here's an image of Lisandro and myself in Python. Awesome. So let's go back to this, right? So think about this guy. This guy failed me because I couldn't write a parser. But I know for a fact that the guy who failed me is writing Python these days. So this guy is using my parser now. So you see, you just need to wait a bunch of time, and the universe will have something to teach everyone. Cool. And this is the interesting thing. The peg parsers are a bit complicated, so it's a bit complex to explain everything. But the interesting part, which will connect to how what I want to teach to you, is that the whole idea of peg parsers is that instead of using these super rigid mathematical constructs when they will do one thing and one thing only, and if you don't do the way they like, they will fail. A peg parser, when you have a rule that has several possibilities, it will basically go one rule at a time trying to parse. And if rule A doesn't work, it will try rule B. And if rule B doesn't work, it will try the next one until one of them works or none of them works. If none of them works, it will tell you that your program is invalid. But if one of them works, it will just use the first one that happens to work. And very simple. Obviously, this is very simple to explain, and this is actually the whole idea of peg parsers. You can explain just with this. But obviously, as you can imagine, this process is very inefficient. So there is a lot of complicated machinery to make this still run in linear time. But conceptually speaking, that's the big difference. The big difference is instead of using the power of math and deducing what of the rules is the one that you need to follow, you just go and try the first thing that works. And if it works, then you're happy. And that's the whole idea. Obviously, there is like a more complicated thing. So you go to the actual parser, you will find that this is not an easy thing. And like parsers doesn't, one consequence of these parsers is that they don't have a concept of failure, because they are basically trying things until one works. So failing to parse a rule doesn't mean that the program is bad. It means that you need to try something else, which is very interesting, right? Like failure is not failure. It means just try something else. That's it sounds like life advice, right? Like suspicious. And basically, they are also super easy to write. Like for instance, if you have three options in your grammar, you just need to write 3 if statements. This is literally how you make a rule parsing in a peg parser. Obviously, the real one is a bit more complicated because it's also made in C, the illegal language. A lot of people ask me why I say C, the illegal language. This is because like some years ago, the White House said that C, writing C was super insecure and that was made illegal. So that was very amusing because people still obviously write C. So I started to call C the illegal language because it's officially legal. So, but CPython is quite illegal. That's the C of CPython. Cool. So peg parsers are cool, but one of the problems is that they are too powerful. In particular, if you say, well, if there were an LL something parser, what will be the something? Is 1? Is 20? Well, it turns out it's infinite, which is like amazing, very powerful, but sometimes it's not that cool. For instance, one of the problems that happened, and this is a real problem that we had to deal with, is that someone went and say, hey, if I try to parse this code, which is incorrect, right? Because it's a bunch of open parentheses and they don't even close and there is a colon. This is just illegal. So Python takes 2 seconds to tell me that this is illegal. And I was like, well, I mean, it's not too bad. I mean, it's like, so it's okay, no? Like, they say, yes, but if I use this, now it takes an hour. Like, okay, person that likes to write illegal Python, let me fix this for you. So the problem of these parsers is that you mess the machinery that makes them not inefficient, then you can have this problem. This was a real bug that we fixed. Here is the bug, right? As you can see, avoid protection, exponential backtracking. And you can see that this bug was upvoted by a person. So someone somewhere now is much happier because he can receive the illegal syntax error in less than a microsecond. Amazing. And thanks, Lisandro. You can see Liz here, obviously, like helping make the world a better place. So it's very cool. And but when you are dealing with like super powerful machinery, like sometimes you need to deal with very complicated errors, right? But something that this parser allow now is to have things like the match statement in Python, which is like something super powerful, but it was only possible because of the peg parser. Like writing this, and every single other person that was parsing Python code had problems parsing this with inferior parsers, just because like it's very complicated to parse, just because you need to know if match is a name or a keyword and is used contextually. Something else that we did now that we have the peg parser that you may have seen is that we are now in a battle to improve all the error messages on Python. So I'm going to show you some of them that we made with the new parser. So something that now the parser does is that it knows when you're missing the colon, or sometimes, for instance, if you're missing, like you have a dictionary but you forget an entry, now it tells you that it was missing an expression. For instance, if you miss a comma, this is one of everyone's favorites, it will tell you that maybe you are forgetting a comma. Wow, amazing. If, for instance, you never close a parenthesis, now it will tell you that a parenthesis was closed. close, which you will say, well, that doesn't sound too complicated. Oh man. Like the error before was something called invalid, EOF found and end of EOF found or something like that, right? EOF stands for end of file, and like I like to think about when they announced that Python was going to be the official language to teach people in France, and I cannot stop but to think of all these like 8-year-old people think like, what is EOF? Oh la la, like. So yes, now it tells you that it's not close. Something that I did with like Butahan was a 15-year-old when I started to mentor him, continue to see Python, and like he's super smart. Now he's a millionaire doing AI stuff in San Francisco. Amazing. It's not just thanks for my teachings, it's just because he's very smart. But something that we work together is to push more these like error messages. And something cool that we did back in Python 3.12, I think, is that if you have like, for instance, this traceback that is basically telling you that you receive a JSON or something like that, and then you're accessing a bunch of JSON keys. For instance, you're accessing A, B, C, and user, and the error is saying that some of those are none because like non-object is not subscriptable. But then if you look at this thing, you say, but which one? And the only way to know is to attach a debugger and like just check which one it is. But after the changes that we did together, now the traceback looks like this, and it will point you to the one that is none. And now you will know, and you will see also that like it will highlight all the parts of the code that are actually failing. So if you have several parts in the same formula or in the same line, it will tell you what part of the line is bad, which is amazing because now you need to touch a debugger. I mean, you still need to solve it, which is the hard thing, but obviously like, at least you don't need to touch entire debugger and lose like an hour there if you are like, just something is breaking on Friday afternoon or something. Not like that happen ever, right? Cool. Something else that I did with Marta, which is another person I mentor, and with Lisandros very recently, is improving the formalization on F-strings. And Lisandros then went ahead and did this fantastic work on T-strings that he presented yesterday. But one of the things that we discovered, like, F-strings were a bit of a hack in the language. So we put a lot of effort to basically format these F-strings and give it a proper grammar. So now you can do things like nest quotes, like you can see that over there, which nobody likes to put all the same quotes in the same thing. So this is an atrocity that now you can do. But now you can do things like adding new lines and things like that. So, like that is something that for me was interesting. And a lot of people think that, when you change things in CPython, we go to this room, right? And then we spend hours thinking, what is the best thing that we can do? But at the end, something that has been very clear to me when I was doing this keynote is that really the way I've been changing things in CPython is by working with friends, right? Like, and this is the thing, right? When we did this thing, I basically worked with to Liz and said, like, wouldn't it be cool if we do this? And it was like, yeah. And we did it. And this is, and now it's impacting millions of people around the planet, which is ridiculous because we are still clowns, but that is interesting, right? At the end of the day, if I could talk with the John Pablo thinking that science is everything and like that's what makes you happy, man, if I could only go back in time and tell them that no, man, like friends is what make you happy, and that's the most important resource that you will gather across your career, right? Like having the respect of your peers, for me, weighs much more than discovering the deepest secrets of the universe, right? So that's something that I have learned across the years, and this is a lesson I would like to tell you. Like at the end, even if you arrive to a super incredible place and then you have a lot of success, if you are alone and you don't have good friends, you achieve almost nothing. So like prioritize friends and whatnot. So this is Gukas and Victor Stinner in EuroPython 2 years ago. So Victor, here I put this image because Victor was the person who proposed me to be a core developer. Back in the day, the promotions were a bit harder because like everybody will vote, and if there is a single negative vote, you will not be a core developer. So when Victor proposed me, there was a single negative vote, and someone says, I don't trust this Spaniard. And Victor, that was the first time someone actually promote a core developer with a single negative vote. So Victor defied the rules for me. So he's also a friend now, and I have him very dear in my heart. Something that I want you to tell you that happened as well is that after the core developer sprint of last year, we were in a dinner with Guido, Emily, Yuri Selivanov, and Lisandros. And something that I like to say a lot in English is like, this is bananas. This is a sentence that I find very funny. And then at the point, like, I don't know who proposed that, but at some point someone says, do you know what you should do? You should give a talk dressed like a banana. And then I said, that sounds very stupid, but yes, I'm in. So we went ahead and did it. This is some stickers that we were giving in PyCon US. Here you can see Yuri Selivanov, the very creator of Async.io and Async Away. He's Russian, so he's a very serious person, but I transformed him into this banana person. This thing went really far. You can see here Yuri and me giving a talk dressed like bananas about our work in Sync.io introspection. But this is even crazier because a surprise that happened after this talk is that Guido van Rossum, which is this guy on the right, also was dressed like a banana. So, like when you're thinking about language design and all these people feeling very important because they work for Microsoft, this is the reality, right? Like this is the banana people being stupid. So, who will tell that the small guy like doing science that he will convince the creator of the language to dress like a banana? This is my real achievement, guys. Like this is what I achieved. The corruption of people. Amazing. Cool. Something that I did as well, I'm super excited to talk about, is with my colleagues from Bloomberg, Matt and Ivona. So we work on PEP 678, which is Safe External Debugging Interface for CPython. And this is amazing, and it's coming in Python 3.14, and you're going to love it. So let me do a small demo of this. So for here in the left, I'm going to have a small Python program that is doing some machine learning bullshit over there. And like now it's doing something weird. So I want to know why it's doing something weird. And before that, you will need to restart the program, maybe with debug statements and things like that. And that was very annoying to do. But since Python 3.14, you can now use this new thing called PDB -p. So now PDB will take a PID. So this is the PID of the program on the right. So you can do this. And in this very scary moment, type your password in front of everyone. And now, whoop, the program stopped. And then I have this PDB session on the right, and I can use it to inspect where I am. I can click next, and look at this. If I click next enough, the program will start to move. You see, it's moving a bit, it's changing lines. And now I can inspect, like, for instance, the local variables here, all the program on the right. So I can see all these stupid weights that are totally fake because this is not a real program. And actually, I can inspect, I can check whatever is going on with my program, and then I can quit my session of PDB, and the program continues running. This is ridiculous. But because this machinery is very generic, something that you can do as well is that you can use this machinery not only to create like big boy debuggers like this PDB thing, but to also alter the execution of the other guy for debug purposes. For instance, you see here, these logs that you are seeing is basically the Python logger on info. You see that here says info, right? So this is because it's logging on info. But this program has debug logs, except that I cannot access those debug logs because I will need to restart the program on the back, right? And that sucks because this program now is doing something weird. Maybe those weights are doing something strange. So something that you can do now in Python 3.14 is write a small script that will I think I have it here. It's called debug something. What it is? Here is activate debug. So this small script, what it does is that it will grab the Python logger and it will change the Python logger on the back. But how can you write this script on the other program? Because this other program is already running. So thanks to this new super cool interface, now you can basically grab the new function called sys.remoteexec, pass the PID of this guy who we have at the beginning, this guy over here. And then you can pass this new script. So I say activate the back, and you will see as soon as I press enter, this guy is going to start the logging on the back. Is this amazing? It's super cool. Coming into Python 3.14. Wow. Cool. So I cannot wait for you to do a bunch of weird things and make all your coworkers angry because you're changing programs on the fly. With great power comes great fun. Amazing. So let's go to the conclusion of the talk. So what was this weird thing? Do you remember this thing? All right. So I will tell you what this thing is. So this thing is the sound of the Python parser parsing a file. So how is that possible? So something I did is that I instrumented the Python parser. And I did basically every single time the parser tried to parse a rule, it will write to a file what rule it was, what token it's trying to parse, if it actually succeeds, and when that happened. So I used that, and then I basically put this thing on a program that was running the entire thing. So I got this like mega multi-gigabyte file, and then I grabbed those information, again, the rule name and the rule and the token name and whatnot, and I transformed that to map that to musical notes in a normal scale, just like literally mapping. I didn't do anything special. And then I converted that to a music file using Python as well. So what you're listening there is literally the sound of the parser doing things. And it's so interesting because you can see how it's backtracking. Every time it has this sequence of like, that is backtracking back again to a different rule. And this is ridiculous because I was hoping for nothing. I was hoping that when I was basically going to do this experiment, I got something like blah, 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 whatever, right? And it turns out that if you do the same experiment with the old parser, or even I try the Ruby parser, you will get nonsense. But this is very interesting because with the Perl parser, you get this stupid musicality. It's ridiculous. Like, this is like, I didn't expect this to happen. And even if you don't know how the parser works, you can almost hear the structure. And there is some weird art there. And this is something that caught my attention, and is the thing that sparked this whole keynote, which is that at the beginning, like, all this structure is quite beautiful, and this is something to actually try to follow, because instead of trying to try to bootstrap your entire thing and like focus on the mathematical strictness of what you think is going to be great and follow your career and I must work at Google and get free lunch, instead of that, maybe a better strategy in life is to basically try the next thing and see if it works, and if it doesn't work, to move to the next thing. And failure is not failure. If failure just means try the next thing, right? And maybe across time, apart from creating these cool files, you can meet new good friends. Like, I should have copied this at the end because it will be a nice end, but like Lisandros. And this is the lesson that I have here for you. Be clowns. Try the next thing. A failure is not failure. It just means try something else. Thank you very much.
Good job, Ryan. That's amazing.